Hello, I'm Eric Benson. I'm an associate professor of graphic design at the University of Illinois in Urbana-Champaign. My talk today is called Fresh Press Agricultural Fiber Paper Lab, the designer as a material science engineer. The idea for Fresh Press was born in brief hallway conversations I had with Steve Cassell, now at the University of Vermont, as we passed one another heading to class or a meeting at the University of Illinois School of Art and Design. These quick discussions led to more formal meetings, and consequently the idea to start a sustainability-based initiative on campus that embraced the natural landscape in East Central Illinois. As a creative research team, we wanted not to discount this ubiquitous landscape, as you see here, but instead embrace it, celebrate it through the arts, engineering, and entrepreneurship. We hope to collaborate with plants, where Earth would be our client. Cassell is trained in various forms of printmaking, papermaking, and graphic design, while I am also a graphic designer with a focus on environmental activism and sustainability. In late 2011, we met after reading the book Caught in the Middle, America's Heartland in the Age of Globalism. It's a story about the fall of Midwestern manufacturing and the failed biofuels revolution. We met to write a sustainability-focused grant with a grandiose mission to help change the paper supply chain from forest to farm. The next year, 2012, we were successfully awarded around $42,000 with a grant from the University of Illinois Student Sustainability Committee. The grant was co-written in collaboration with the Sustainable Student Farm to buy papermaking and farming equipment. We plan to create University of Illinois paper more responsibly and empower others in the community, campus, and beyond to do so as well. We intended to develop agricultural papers made from local crops like corn stover, rye, soybean waste, sunflower, and prairie grass that could provide an alternative and better paper that could slow deforestation and reduce carbon emissions. We also believe that we could demonstrate that when agri-fiber paper waste papers are made, they create an additional source of revenue for local farmers, reduce transportation carbon emissions, and prevent needless burning of crop residues that contribute to global warming. In addition to these goals, we wanted to eventually help return manufacturing to the Midwest by using what is already here, the farming industry and the geographic landscape, to create sustainable paper and paper products. Fresh Press wanted not to grow crops from paper, but instead capture the byproducts from the regional harvests. The objectives there was to experiment with different fibers and blend ratios to create repeatable recipes that could be licensed and scaled up to large-scale paper manufacturers in the Midwest and beyond. Compared to tree fiber, typically harvested in northwestern Canada and shipped south, regional agri-fiber and consumer waste paper emit significantly less carbon emissions since the transport of raw materials are localized. In a study I did in 2018, using the Sustainable Minds life cycle analysis software that you see here, I found that prairie grass had a 66% smaller carbon footprint than traditional tree fiber paper. If Fresh Press had been using renewable energy in all areas of paper production, including the harvest, prairie grass paper would have a climate positive outcome. Or in other words, we'd have no negative climate impact at all, and instead be drawing down greenhouse gas emissions through improving the soil with the fields of prairie grass. We had an inclination that agri-fiber papers would have a much smaller impact on the environment from the outset of this project, but we needed the science and the data more so than what I show you here to prove our point. So we set additional goals for Fresh Press that including ways to reduce our overall water use in manufacture, reuse water in manufacture, develop rainwater and gray water sources, develop and employ energy-saving techniques, and seek additional funding for renewable energy sources as well. We also intended to employ student workers in a cooperative employee-owned model and look to be self-sustaining via revenue from paper sales. We correctly predicted that this would require more funding and buy-in from the university and require additional research partners. One of those partners was architecture professor Jeff Poss. Together we raised $68,000 from the Student Sustainability Committee to build this wash and pack pavilion with his graduate students from his class entitled Small Studio. On the land, the campus sustainable student farm leased from the university. Here the funding was aimed to help the farmer, Zach Grant, increase his yields and store fibers for us at Fresh Press. It was a symbolic and pragmatic way to signal the start of a symbiotic partnership with the farm to begin our experiment of not only papermaking with agricultural byproducts, but also a cottage industry where unwanted harvests could be sold to Fresh Press and then, in turn, manufactured into paper and sold to consumers. We were going to grow our own paper. The funding helped Fresh Press secure 2 research assistants, the amazing Megan Diddy, who got an MFA in painting, and Eva Cherdow, who got her MS in Library and Information Sciences. They were instrumental in the paper research and commissions that we had. Despite originally only starting Fresh Press as a research facility, the paper gained a lot of attention from regional artists who ordered the paper, and we began to rethink the options to branch out as a business. Here you can see some of the images from our studio. We worked with the university to set up paper sales account to accept online purchases. This account helped us test the possibility of operating as self-sufficient business, in addition to managing a research facility, selling paper, and putting that revenue back into supplies, labor, and marketing. These collaborations, like here you see a project we did with Jeremy Chen, were outside of our normal research activities for both of us. When the Fresh Press project started, we assumed that we could enter into new research territories as designers and artists, but it was unknown how or what areas. As a designer working with a farmer to help plan a growing season to best decide what fibers were interesting to form paper was a new and daunting challenge. Furthermore, knowing what fibers would make the strongest or best papers for writing or different forms of printing and art were a guessing game until they were made and tested. On top of this, it was possible that a blend of multiple different combinations of fibers was the answer, and not just one. We needed further guidance, as we were not material science engineers yet. In 2014, Fresh Press was invited to participate in the National Science Foundation's Innovation Corps, or I-Corps. This semester-long program uses experiential education to help researchers gain valuable insights into entrepreneurship, starting a business, or industry requirements and challenges. We were looking to better understand the market for our sustainable agri-fiber paper products and the best way to tell our story to possible collaborators and consumers. This intensive program asked every participant to develop a business model canvas, where the participants located their key partners, activities, resources, value propositions, channels, customer relations, and customer segments. This involved brainstorming amongst the team, deep industry and marketing research, and connecting in person or over the phone with hundreds of experts and potential customers in the market sectors determined by our business model canvas. The program required a presentation after the 4-month deep dive, and we learned some very important information about the market for our paper products, a snapshot of our most likely customers and what it would take to reach these people. First, through close to 50 interviews, Fresh Press discovered that agri-fiber pulp packaging, as you see here, was the best area to focus on in our upcoming research, as it was highly desirable to fill a need in the marketplace. We found that our target demographic was called the Lifestyle of Health and Sustainability Market, or LOHAS. These consumers and citizens see strong connections between their personal health and the environment. They make their economic decisions to further improve the world we live in. It was also learned that Fresh Press could also be effective in reaching new customers outside of LOHAS market by creating messaging that explains how using and manufacturing agri-fiber paper products help the American farmer. Everyone wants to help the farmers, it was learned. In order to achieve Fresh Press's mission, we determined that we had to prove, with scientific data acquired through engineering tests and life cycle analyses, that the sustainable paper products we created were actually better not only for the planet, but superior than tree fiber paper. This would require a whole new level of partnership and funding outside of what was common for the artist and designer. So typically, the artist and designer in their collaborative research partnerships were centered around how we can work better with other disciplines and to create new knowledge or better tools or methods to work together. This is very common. What we were challenged with here was to learn about what characteristics of our paper through scientific testing And we were interested in finding a research partner who had the laboratory and skill set to determine these characteristics so we could prove to the market that our paper was better for the planet and better than tree fiber paper. And this type of research was outside of our expertise and would be new to the graphic design field in regards to sustainable material development, testing, and manufacture. Now, we were aware of graphic designers writing about and exploring sustainable materials, but not any who were actually making these materials themselves. 2 years later, in 2016, Steve Costell left for the University of Vermont. I raised an additional $14,500 from the University of Illinois with 2 new partners. Mechanical science engineer Sam A. Tofik, who you can see here, and Professor Mark Taylor from architecture, with a grant called 3D Pulp Crop Residue at Small and Large Scales. The grant was targeted at finally working with an engineer in their lab to collect data on the characteristics of our paper in 2- and 3-dimensional forms. And again, we learned this from our I-Core class. This project took our studio into entirely new ways of working. To best collaborate with our new partners, we had to move away from functioning like an art studio and follow more strict protocols to keep weights and portions accurate every time we cooked and beat fiber, handmade a sheet, or created a fiber cube, like you see here, for testing. With the help of a new student research assistant, Laura Kavanko, and Professor Tofik, we created a system modeled after the scientific method of observation, hypothesis, formation, testing, and retesting to produce different varieties of pulp to hand-make paper and cubes at the same time. We also created a strategy to produce blends of various percentages of different fibers in pulp, sheet, and 3-dimensional forms, which are basically cubes cast in molds. We needed to determine the characteristics of each. I transformed, in the end, my art of papermaking into a science. And here you can see some data that we collected on some of our corn cubes. In this research endeavor, we limited our fibers to hemp, rye, corn, and ash, using wood fiber as a baseline comparison. We also blended and tested each of these agricultural fibers with 50% of recycled cotton, except for the ash. In Tofik's lab, we measured length, width, mass, density, volume, stress, as you can see here, and stiffness. We further looked at each under a scanning electron microscope to analyze the fibers at different scales, to possibly correlate data collected with the visual characteristics of each of the fibers. For instance, rye looks like zippers or sawtooth blades the closer you zoom in under a scanning electron microscope. We theorized that possibly the good strength and stiffness numbers for rye in comparison to other fibers might be due to the individual fibers interlocking like a zipper when formed into a sheet of paper or 3-dimensional form. Our collaboration with Mark Taylor on this grant involved a different way of using fibers in 3 dimensions. With Tofik, each fiber cube was approximately 2 centimeters in length, width, and height. With Taylor, we scaled up these forms to paver or brick-sized blocks. The intentions here were to see which fibers are best for commercial or residential building materials. The data collected from Tofik, which were in 2 centimeter cubes, was used to choose which fibers could be used to create larger forms, combined with environmentally friendly geopolymers for thermal resistance testing. This is best described as the measure of resistance to heat flow through a given thickness of material, or R value. Professor Taylor's goal was to build a full-scale wall from the material that had the best R value for insulation purposes. Here are some of our final results in the Krannert Art Museum. The research from this grant was published in the Proceedings of the World Multidisciplinary Civil Engineering and Architecture Urban Planning Symposium in 2018, held in Prague, Czech Republic. As that funding dried up, I needed to find a new way that I could think about my studio and lab. I attempted to write grants for further collaborative projects in the sciences, but was unable to find any that matched in the art and design field. This is most likely because the area of sustainable material development as a form of recognized research within the arts is a new one. I needed to rethink what I was going to do next. And my idea came through the idea of a CSA, or Community Supported Agriculture. I raised around $38,000 with the new farm manager, Matt Torino, to create a CSA of handmade paper and art prints on that paper. It was run by entirely university students from painting, graphic design, landscape architecture, and advertising. I taught them about hand paper making, business, land stewardship, and sustainability. They called this project Fiber, and it reinvigorated the studio with new faces and brought the creative practice back into focus. It was a nice side venture as it showed the capabilities of the designer to be able to move back and forth with some ease between science and humanities-based collaborations. We gained a lot of exposure on campus from this, but one of the things that we were asked the most was about workshops for schools, organizations, and individuals. One of the inquiries came from the University of Illinois Conservation Lab in the library, who is now my current collaborators. Our collective goal is to create a proof of concept case paper. As you can see here, the case paper is used in the binding of hardcover books. We wanted to make a locally sourced and produced paper for cultural heritage conservation. We hope to test this material to determine chemical characteristics and to determine the best source of production and the details of all the new papers. We needed to analyze all these resulting materials in the conservation setting to ensure practical use in the field. Currently, the Conservation Lab uses case paper that they purchase from other vendors, but as those companies have slowed or stopped production, we now have the opportunity through this partnership to design and manufacture Illinois-specific case paper with regional sustainable materials. So we've been at this for about a year. And we've been testing fiber blends in engineering and chemistry labs on campus to find the best case paper for the library to mend old and damaged book covers and potentially sell to other libraries across the country. Currently, after all the data collection, we have determined a definitive fiber going forward. And we hope to manufacture this paper. This project has transformed our studio again away from an artist practice to a scientific lab. The chemist, Annika Vetter, leading the testing side of the project, has improved upon our past models with Tofik and Taylor to one that also has completely reorganized the flow of the studio space to better accommodate the scientific method in a studio setting. To help hire more staff and support the purchase of new supplies and equipment, including a rocket stove to cut down our carbon footprint even further, we received a grant for around $14,000 from the university library. This financial support helped us test papers for flexibility, folding, as you see here, for pH and opacity, as you see here, and also aging. And this is an image from our aging oven where we can age paper up to a couple hundred years. Combined with the data from previous research, we were able to locate a viable paper blend that we can make uniformly and at a larger scale for use in the University of Illinois Conservation Lab and possibly other libraries. We call this product, and here's some more data collected, we call this Prairie Paper. So in conclusion, Fresh Press has been a new venture for me personally as an academic, but also unique as a research outcome in the field of graphic design. Typically, writing, presenting, developing new tools and methods, and making with materials are acceptable modes of research dissemination for promotion and tenure in academia. I am not only making with sustainable materials, but also creating those materials myself. Currently, my lab is the only agri-fiber papermaking research facility operated out of an art and design school in the country. It's generated new knowledge on sustainable material manufacture and has very importantly opened up a new area for design research outcomes, sustainable material development. The mission Steve Costello and I chose from the outset of Fresh Press is still the goal, to change the paper supply chain from forest to farm. This will take increased support from industry and the everyday consumer. It's a grand challenge. Our successes from the collaborations have shown that agri-fiber papers do indeed have a smaller carbon footprint than that of tree fiber. In fact, prairie grass paper specifically made with renewable energy sources can be regenerative for the soil to create climate positive solutions. So hopefully, through the continued advancements in sustainable paper research here at Fresh Press and beyond, I can open doors for new accessible areas of design research outcomes and a better climate future. Thank you. If you're interested in learning more about my work, you can email me at ebenson@illinois.edu. You can check out my website at freshpress.studio, and I'm on Instagram at freshpresspaper. Thank you very much.